Hello students, in the previous class we have learnt about the oxygen, which is one of the most important constituent or one of the most prominent constituent of the air. So students, oxygen is needed for combustions. That means you might have already studied in the class. I have told you that chemically oxygen is very reactive element, and this oxygen combines with the non-metals and the metals. Of course there are some exceptions like gold and silver and platinum is there. So when this oxygen combines with the metals or the non-metals, then the respective oxides are formed. Like suppose if oxygen combines with the carbon, then oxygen is a non-metal, so it will form the carbon dioxide, its respective oxide. And this reaction of a substance with oxygen is called the oxidation reaction. Now it is burning or combustion. It is an oxidation reaction in which energy is liberated, but in certain forms it is liberated, that is heat energy, light energy, and sometimes the sound energy as well. And these three are the conditions which are required for the burning, that is the presence of combustible substance, oxygen in the air, and attainment of the ignition temperature of the combustible substance. That means we must have a substance to which we are burning, then air must be there, and in the air oxygen must be there. Then ignition temperature should be attained. Ignition temperature is that temperature at which the particular substance will start burning. Now students, uh, depending upon the rate, oxidation is classified into the three types, that is spontaneous oxidation, rapid oxidation, and slow oxidation. Spontaneous oxidation is the one which takes place very instantly. Like you might have seen, like in this spontaneous oxidation, no external heating is required, and this type of reaction is called spontaneous reaction. Like sodium is there, phosphorus is there, potassium is there, they are very highly reactive with the oxygen. So therefore they are kept, like sodium is kept in the kerosene, potassium is kept in the kerosene, so that it can be, so that a restriction is made, and the sodium and potassium should not come in contact with the air, because it has oxygen in it, it has moisture in it, and it will it will react with the that particular element. Explosion. Now next we have is the explosion. Now it is a very sudden oxidation reaction that takes place with the release of a large amount of energy in the form of heat, light, and sound. You might have seen the firecrackers, no? That is the perfect example of the explosion. So we have to ignite it, that means we have to heat it, external heat is required, and then the explosion takes place. Now rapid oxidation, then there are certain substances like petrol, kerosene, LPG, etc., paper and all, they burn very rapidly in the oxygen. When we heat them, when we ignite them, when we burn them, then they show rapid oxidation. Slow oxidation, rusting we all know, respiration we all know. So these are the slow processes which takes certain time. So the oxidation of that particular metal, like in case of rusting iron, oxidation of iron takes place very slowly. Now students, reaction of oxygen with the non-metals, like carbon, as I have told you, it burns with the oxygen, it combines with the oxygen and form carbon dioxide and gives heat. And this carbon dioxide, this combines with the water and gives us the carbonic acid. Next up we have is the sulfur. The sulfur reacts with the oxygen and it gives a bluish flame, and this bluish flame, it forms a pungent smelling, colorless and suffocating gas, and that is the sulfur dioxide, which you can see here, which is a product of sulfur and oxygen. And now this sulfur dioxide, when dissolved in the water, it forms sulfurous acid, that is H2SO3, not H2SO4, that is sulfuric acid. This is sulfurous acid. Then we have phosphorus. When it combines with the oxygen, it gives us phosphorus pentoxide, and when this phosphorus pentoxide combines with the water, it gives us the phosphoric acid, which is H3PO4. Likewise nitrogen, which when reacts with the oxygen at very high temperature, then nitric oxide is formed. You might have seen the lightning during thunderstorm and all. So that is when nitrogen and oxygen in the air, when they combine together, Now this nitric oxide will further react with the oxygen in the atmosphere, and it will give nitrogen dioxide. And when this nitrogen dioxide will react with the moisture present in the air, then it will give us nitrous acid and nitric acid. And this nitric acid falls down along with the rain on the surface of the earth, and that is what the acid rain is. Now we have is the reaction of oxygen with certain metals. So if you see sodium, when sodium reacts with oxygen, it forms sodium oxide and gives heat. And when this sodium oxide is made to react with water, then it gives sodium hydroxide. And when when it combines with the oxygen, it gives potassium oxide, which is a respective oxide of that particular metal which we have read, and it will give you heat. And when this potassium oxide will react with water, then it will give you potassium hydroxide. Likewise, calcium, which is a metal, when it reacts with the oxygen, it gives calcium oxide, and when this calcium oxide is dissolved in the water, it will give calcium hydroxide. And when a piece of magnesium is introduced in oxygen, then magnesium oxide is formed, and along with this, heat is liberated. Now this magnesium oxide, when this will be dissolved in water, then magnesium hydroxide will be formed. Likewise, when iron and oxygen, when they combine together, they form triferric tetroxide, Fe3O4.